Right now, somewhere in the world, a product designer is staring at a CAD screen. They're working on the schematic for a brand new piece of consumer electronics. But the decisions they're making at this exact moment, they aren't just about aesthetics or even basic functionality. They are making absolutely crucial choices about alternative materials, complex supply chains, and power consumption. So, welcome to this explainer. Today, we're diving into the massive shift happening across the electrical and electronic equipment industry. We'll be using the SASB Sustainability Accounting Standard as our guide to see exactly how ecological responsibility is literally being engineered right into the circuit boards of our daily lives.
Here is our roadmap for today's explainer. 1. The circular design shift. 2. Eliminating hazardous chemicals. 3. Certifying energy efficiency. 4. The product use phase. And 5. The clean tech financial upside.
Okay, part 1. The circular design shift, where sustainability begins.
So this entire shift is built on one big realization. You can't just manage waste at the end of a product's life. You have to design the waste out from day one. Electrical and electronic equipment companies are facing a ton of pressure right now regarding the environmental and social impacts of their products. Because of this, regulations are heavily incentivizing these entities to reduce their environmental footprint, specifically when it comes to harmful chemicals and energy intensity. And you know what? All of that starts at the conceptual design phase. The choices made right there at the CAD level essentially dictate a product's entire environmental destiny.
Moving on to part 2, eliminating hazardous chemicals. What's inside matters. Because when we talk about eco-design, we absolutely have to talk about the physical materials themselves. Let me ask you, what exactly is inside our electronics? I mean, we interact with these smooth glass and metal rectangles all day long, but hidden inside is a wildly complex chemical mixture. To put that into perspective, a single smartphone can contain up to 60 different elements from the periodic table. Historically, manufacturing these components could involve heavy metals or other really toxic substances. Managing that isn't just an operational headache, it's a massive regulatory challenge.
To solve this puzzle, the industry relies on specific frameworks, like IEC 62474. It sounds technical, but it's basically a material declaration standard specifically designed for the electrotechnical industry. It tracks potentially harmful substances anytime they appear above specific reporting thresholds. SASB actually uses this as a core metric, which they designate as RTESE 410A.1. Under this metric, companies are asked to disclose the exact percentage of their products, by revenue, that contain these declarable substances. It's all about creating total transparency regarding what is physically inside the equipment they're selling to us.
So, the crucial question is, how does a company actually manage this day-to-day? It's not just a reporting exercise, it's a deeply operational one. According to the standard, product designers and engineers take some very practical steps here. First, they cross-check their product design criteria against banned substances lists. Second, they conduct material substitution assessments. That means they're actively out there looking for safe, non-toxic alternatives to swap in. And third, they update their materials and parts procurement guidelines, which ensures that their entire supply chain actually aligns with these safer product declarations.
All right, part 3, certifying energy efficiency, proof of performance. Now, once you've successfully designed a product with safer materials, your next major challenge is proving it actually uses power efficiently. Not every product is judged the same way, of course. The standard specifically looks at eligible products that are certified to an energy efficiency certification. You know, I'm sure you can visualize those bright energy efficiency labels stamped on new appliances. In this industry, eligible products typically include the heavy hitters, things like uninterruptible power supplies, massive HVAC equipment, as well as industrial lighting and fans. These are the categories where efficiency makes a literal, measurable difference to the power grid. And how is all of this tracked? Well, once again, by revenue percentage. But this metric isn't just a boring compliance rule. Tracking the percentage of eligible products certified to an energy efficiency standard by revenue acts as the ultimate scorecard. It tells investors and consumers like us exactly how successful a company's eco-design efforts really are. It shows how competitive they are in a market that increasingly demands high performance combined with a really low energy draw.
Which brings us to part 4, the product use phase, the long-term impact.
Now we get to step directly out of the factory, off the store shelves, and right into the consumer's home to measure the real-world impact of those early CAD choices. The standard defines an energy-efficient product as one that's tested and modeled to establish a proven increase in efficiency during its actual use phase. This timeline really makes that abstract concept concrete. In year 1, the end user sees an immediate reduction in their energy use. By year 3, those daily energy savings have compounded into real, cumulative consumer cost savings. And by year 5, the product has contributed to a highly measurable, long-term environmental footprint reduction. These design choices quite literally pay off for years after the product is unboxed.
But we need to make an important distinction here. We have to compare meaningful energy reduction against minimal ancillary efficiency. In other words, no loopholes allowed. The framework explicitly excludes products that only impart resource efficiency in a minimal or indirect way. So if a company just makes a conventional product slightly lighter than last year's model, yeah, that doesn't count. The improvement has to be a meaningful, measurable increase in energy efficiency to be recognized as a true clean tech innovation.
And finally, Part 5, Clean Tech Financial Upside, Sustainability as a Revenue Driver.
This brings us to the most compelling piece of the entire puzzle, the bottom line. These complex ecological design choices we've been talking about, they actually present massive financial opportunities. Specifically, looking at metric RTFE 410A.3, companies are required to disclose their total revenue from renewable energy-related and energy efficiency-related products. This is where financial markets bridge that gap between doing the right thing ecologically and reaping the financial reward. By tracking this revenue, companies can definitively prove the market demand for their sustainable innovations.
So what exactly is driving this new revenue? The standard provides some fantastic, concrete examples of these high-efficiency innovations. We are talking about smart grid technologies and infrastructure, like advanced metering equipment. We're talking about demand response systems, highly intelligent building and smart home controls, low-loss transformers, and flexible alternating current transmission systems. These are the exact products that are modernizing electricity delivery and optimizing energy use across the board, and they represent a huge growth vector for the industry.
When you chart this out conceptually, tracking revenue from traditional electronics versus clean tech and efficiency revenue, you see the business case crystal clear. Documenting revenue from things like smart inverters or renewable energy balance-of-plant equipment absolutely proves the financial upside. It shows investors that the company isn't just resting on its legacy hardware, they're actively capturing market share in a rapidly expanding clean tech economy.
There's a quote from the SASB standard that I think hits the nail on the head here, and I want to read it to you because it perfectly summarizes the stakes. It says, "Electrical and electronic equipment entities that develop cost-effective products and energy efficiency solutions may benefit from increased revenue and market share, stronger competitive positioning, and enhanced brand value." That firmly establishes that strong environmental performance isn't some sort of penalty. It translates directly into stronger competitive positioning. So, as we wrap up this explainer, I want to leave you with a question to really ponder today. Take a second and just look at the screen you are watching this on. Think about the physical hardware powering it. What invisible design choices went into the device you're using right now? How much of it contains safe, declarable substances? How efficiently is it pulling power from the grid during this exact use phase? The answers to those questions don't just determine the health of our environment. As we've explored today, they literally determine the financial future of the tech companies that built them. Thanks so much for joining me on this deep dive. Keep asking those big questions and keep looking for the structure behind the products we use every single day. See you next time.